I'll introduce myself. There is somewhere the slides in between where there's this section about me. But first, let me say I'm really happy to be here. And today we are going to talk a little bit about monorepos, right? This is why we are all here, specifically Nx. So you've already shown who used Nx. You are maybe wondering if it's worth the effort. So today, what I really would like to share with you is actually how Nx works under the hood and why its architecture makes such a big difference when you are dealing with monorepos. So hopefully some questions that have been addressed in the previous talks will address through my talk as well. So, for those who did not use Nx at all, what Nx really is, it's basically a build system and development platform that helps you manage monorepos. So the size doesn't really matter. You can use Nx in very small projects as well as on this large-scale application. The official Nx docs define Nx as technology agnostic build platform, which means it doesn't really care if you are using Angular, React, or whatever technology, even some backend technologies like Java or .NET. And the real win with Nx is that it helps you get from writing the code to the green merge request very fast. So when your code grows and your kind of team grows within it, your productivity bottlenecks multiply. And Nx addresses this through its graph-based architecture, smart caching, and buildable libraries, incremental build. These are not the only features that Nx provide, but we would spend here like a week trying to deep dive into each of every tool and feature. So let me limit my talk only to these three. But hopefully, once we understand the core, we'll be able to understand everything else. But before we'll dive deep into the source code of Nx, let me quickly introduce myself. My name is Jarek. I've been working with JavaScript since I remember, I would say 18, 19 years or something like that. I am the Angular GDE, trying to be active in the community as much as I can. Not always have a time, but yeah, at least trying basically. I'm kind of fascinating of the front end, how things works under the hood, trying to debug every bit. If you have any questions, feel free to reach me out. You can find me on Twitter as well as on LinkedIn or in person. Basically, I'm from Wrocław, so don't have like far away. So. Let me start with explaining maybe how Nx thinks differently about monorepos than the traditional build tools. So the traditional build tools treats every project like we have project A, project 1, project 2, project 3 as a separate isolated island basically. And each of these projects got their own things inside, including the definition how to build this project basically. So Nx flips this idea completely. So instead of isolated projects, Nx creates something that is called a project graph. So think of it like this. Each of these projects is a dot on a map, and the relationship between these dots are these lines connecting this project. So it's not actually like the pretty diagram, it's not about that. It's more like how Nx understands your code base and how Nx understand the dependencies and how Nx use this knowledge to make some smart decision, including what need to be built, what could be tested, what could be skipped. Right, so the key insights here is that at least in my opinion, understanding this relationship is as important as understanding the code base itself. So once Nx knows about everything, all these connectivities, all these relations, it can figure it out what's the affected pipeline, so what projects should be rebuilt once we'll change some piece of the code, or to determine the best order to run task, or maybe identify which parts of the code need some more attention. So what I really love in Nx is the fact it's modular. So we don't really need to grab everything at the beginning. We can just start with the core, then we can add more and more and more features once we need them, of course, so there is no huge barrier to entry. We can just start small and grow our setup as our needs grow. So let me dive a little bit deeper into this core package, because I do believe once we'll understand how this core works, it will help us to understand how the other features works as well. So when we are working with any workspace like npm, pnpm, yarn, or whatever, basically any build tool can run your script from the package JSON, right? It's not a big deal, basically. And Nx can do that as well. But Nx will do that with a complete awareness of how your projects relate to each other. And this is really important, because this awareness lets Nx optimize the task execution, the build execution, in a way that the traditional task runners just simply can't do. And hopefully I will prove that in the end. So let's talk a little bit about this awareness, because this is like the truly basis of how Nx works. And many people think of it like the way it's created just once and just sits there. Actually, it's a little bit more dynamic than that, basically. So every time you run the Nx command, there is this orchestration I'll show during the demo that is happening behind the scenes. Probably none of you just wondering how it's working, but it's very, very fascinating. Once we'll understand it, the mechanism will understand that it's not just like another build tool. So when we'll type something like Nx build my app, there is like the whole process that is kicking off, and let's try to understand what's going on when we'll start typing the Nx build my app. So for that, let me quickly use the Nx repository, and I will walk through the source code of the Nx, trying to explain what will happen when we'll run the Nx build my app command. So the mentioned process starts in the run command method, and it's not just like run the build method. It's more like first figure it out what's going on in your workspace, and then run the build intelligently, basically, right? So the first thing it does, it calls run command for task method, which is where the real world starts. So one of the piece of this run command for task is the ensure workspace is in sync and get get graphs. And this is where Nx basically says, hey, hold on, let me figure it out if I understand everything what's going on. So, it's checking if anything has changed since the last time when it looks. If it finds something, it's just updating, rebuilding the dependency graph. So it's not just one-time thing. Nx will constantly try to be up to date with the state and in sync, trying to have like our workspace fresh. Now, yes. Now, once we'll have this solid understanding about all this relationship, it moves to this method, create task graph and run validation. And here things gets really interesting because Nx doesn't really think about projects anymore. It starts thinking about the tasks. So it grabs this dependency of the projects and transform it into the task project. So the actual task creation happened in, here it is, happened in the create task graph method, and this is where Nx shows it's really intelligent and smart. So in this create task graph, we have this new process task instance. And here is, this is like, just by the way, a little bit boring name for such a crucial method or class, but this is like the brain of the whole operation. So it takes our command like build my app and figured out what task need to be done to make it possible, right? So we can see the one line below, there is this process task method call based on this instance. And in this process task, because this is the fragment of the process task method, there is this methodical approach where Nx goes through each task and call the process task of every single task, asking, hey, what this task actually depends on. So it creates like this relationship and awareness of what's your dependency. And when it comes to analyzing these dependencies, for analyzing these dependencies, it calls this getDependencyConfig method, where Nx grabs your configuration and identify all different dependencies, not only these obvious ones, but actually, all the dependencies, meaning dependencies of the dependencies of the dependencies, and so on. And what's really clever is how Nx connects this all together, basically. So the project graph can tell you project A depends on the shared lib. However, the task graph is a little bit more specific. So the task graph tells you to build project A, first I need to build shared lib. And in the end, based on this awareness, Nx kind of transform this knowledge into a very specific execution plan. Now, let me get back to my presentation. Right? So this whole process happens every time when we run this command, basically. And what makes Nx really smart is this knowledge about how different projects are connected all together. So when we'll add a new dependency, Nx will automatically take it into the consideration when we will run Nx graph. If we'll change anything in the configuration, Nx also will pick it up automatically. Now, that's weird. I will okay, not sure why this slide is empty. However, there should be like a project graph after running the Nx graph, which is yeah, poisoned cache. But yeah, like I see, like not sure why it's not displayed. I'm sorry. But when we'll take a look at the Nx graph later on, and it's pretty cool to explore. So I will show the effect of running Nx graph. But this is just the results of all this orchestration we walked through, right? So the Nx graph is used to enable some different Nx features, like identify the affected pipelines, like determine what's the best order to run the task, or we can use this dependencies graph to understand project relationship a little bit more, or to even analyze some different impacts. So what will happen when we change some different files? Yes, the next slide exists, so fixed. So let's talk a little bit about caching. So Michael done a really great introduction, and I will cover many things he did mention, but from like how it's working under the hood. So yeah, if you'll have any additional questions to Michael's talk, please address them after. So what's really fascinating for me when it comes to the Nx cache is it's not just like a typical cache mechanism. It's not just serving you a files that, or saving you a files that you will reuse later. It's like way more sophisticated than that. So it's understanding your entire workspace on a very deep level. So let me walk you through the implementation details of this mechanism. And let's start with the task hasher. Here it is. Right. So Michael talked a little bit about the hashing. So there is this task hasher class, and this task hasher class defines this get inputs method, and this get inputs methods do some really serious detective work for us. So it's analyzing what Nx calls depth inputs, self inputs, depth outputs, and project inputs. This means it understands not just the fact that cache is invalid, but having all these informations, it understands why the cache is invalid, right? And the hash calculation itself happens in the where am I? Here. Happens in the hash task method, and this is where things get really interesting, because it creates something that is called a partial hash. So we can see the returning value of hash task method is promise of partial hash. What is partial hash? Well, partial hash is an interface that stores the value of the hash, but additionally, it also stores all the details about your hash. So, this is what Michael exactly described. When you have a cache hit, you have exactly the same experience as you would run the task. So you have all the outputs in the terminal ordered and executed and displayed in exact the same way as without this cache hit. So yeah, thanks to all these details, Nx knows not just the cache is invalid but also, like I said, why it's invalid. Now, when it comes to storing the cache, Nx got two different implementations, the deprecated one and the new one. So dbcache is this new class, and the cache class, which is annotated as deprecated, which is an older cache class to store the cache, basically. What's really important is switching between these two is no drama, basically. So both follows the same interface, and we can just clearly, pretty straightforward, use both. Now, here's where things get fun. So when we need something to grab from the cache, it's like first checking if I have my money in my pocket before going to the store, right? So I'm checking if I have my wallet, if I have my money. If yes, then boom, it's done. Basically, there's no task execution. You've got your results, and you don't have to do anything else. If your cache is found locally, the remote flag is set to false. However, this is not always, that optimistic scenario. So if your local cache is not found, then it's like calling Joanna, for example, to borrow the money before I'll go to the store, right? And if I'll call my colleague to borrow me my money, then I'm calling the remote cache.retrieve, and I got my money from the remote cache. And what's really important is that it's not just used once. So once we'll find the data, the artifacts in our cache, remote cache, Nx save those data using the apply remote cache results method here. And this method saves those data for local cache to be reused once we'll request them again. So, it's so smart that it limits us, or it helping us to find always things locally. If not, then we are calling the remote server, and if it's not get in the remote server, then we are actually rebuilding things from this from scratch. Now, let's flip this a little bit around, so we know how Nx gets the data. Now let's walk through the saving the data into the cache. So there is this put method, and this put method is like making a snapshot of everything. Everything, when I'm saying everything, I really mean everything, because if you'll take a look, the arguments of that put method, it's taking a hash, it's taking a terminal output, it's taking the output files, even it's taking the exit code, right, from the terminal. So once we'll have this cache hit, we have exactly the same experience as we would not have this cache hit at all, basically. Where is it? Now, when it comes to the Nx, what I really love when it comes to the cache is this method getRemoteCache, because this method shows that Nx doesn't play any favorites when it comes to the cache providers, right? Here it is. So in this getRemoteCache method, it's like speed dating through different options. It's starting with NxCloud. Well, if it's not available, then cool, let's check S3. If no S3, then maybe Azure, GCS, or maybe we've got our own HTTP cache available, so we are not locked. The decision is on our side. Now, there is more, basically. So I did say about orchestration, all of these things. So there is this class task orchestrator, which organize things in a very smart way. So Nx shows here that it's not only smart, but also really efficient. So when we're restoring a cache results, it doesn't just blindly copy everything from the cache. In this apply cache results method, we have this flag should copy outputs from cache, which determines actually if should we actually make a copy of this file. So this is very efficient, and if this flag is set to false, it means that there are already artifacts stored in our local cache, so there's no need to make any copy. And the way all this waves into the task execution, well, there is this before run phase where we are calling apply cache results. So first, before executing the task, we are checking if there's some artifacts, pre-made distributed artifacts stored into the cache, determine if we should just restore them or not. If we've got a local cache, then we are done. If not, then we are asking remote cache.retrieve. If there's no anything in the remote cache, then we are running run batch method, which is actually something that run our task. And in the end, when we'll have all the outputs from the task execution, just in case we are executing this cache.put method, which stores the results into the cache again. So the next time we'll execute exactly the same command, there will be again a local cache hit. All right. The performance impact is real because on every step, Nx checks, it's not about how to avoid different repeated computation. It's more about understanding the project relationship and use this knowledge to make very smart decision about what could be skipped entirely, what can be cached, what needs to be invalidated, how to restore cache results efficiently. Sorry. Right. Let's switch gears a little bit and talk about not completely separated topic, but something that was touched by Adrian, and let's talk about the incremental build. And the incremental build utilizes the graph generation and utilize the cache mechanism to make it work such an efficient. So think of it like this. Instead of maybe cooking the entire dish every single time from scratch, we are using the leftovers really smartly, right? So Nx figures out what actually changed, what needs to be rebuilt, and do absolute minimum work to get it done. And maybe you are thinking that minimum work doesn't really or sounds like a lazy, but I would say in Nx world it's called efficiency. So when we are taking a look into the project graph, we can see that project A depends on project B. When we are taking from the other hand on the task graph, we are seeing that to build project A, first we need to build project B, which is natural, like you can't really eat a cake before you will bake it, most probably. And here's the golden rule. Buildable libraries can depend only on another buildable libraries, which makes sense because if we have some dependencies that does not have any build target, we don't have anything to build, so it's not treated as the task dependency, it's more treated as the project dependency. What makes some buildable libraries special? Well, it allows this incremental build feature, that first point, but when we build actually the library, it produces a distributable artifacts that store transpiled TypeScript code, type definitions, maybe sometimes manifest or the bundle code basically, and store these results into the cache. So it's very similar to what we see when we are installing the npm packages. We are downloading only the already built code. So the other projects that needs this particular pre-built projects, the consumers can use these pre-built artifacts instead of rebuilding them from scratch. Now, the incremental build strategy needs this caret symbol. It's like saying build all the dependencies first, then build me. Very simple but really powerful. And here is where it gets really smart. So if something or if the dependency has been changed, it's just rebuilding it, constantly asking what's the minimum work to do to make it work. If the dependency is not changed, then it's asking, why should I rebuild that, right? I have these artifacts already into the cache, so instead of rebuilding, I should just download it from the cache. Now, let's talk a little bit about numbers, because this is also a really important thing. So I have prepared a very small project, however, with and without incremental build enabled. So here we can see results of building this project without incremental build. And we can see the whole project is built as one piece. So there is no buildable libraries, there is no task dependencies. What's pros, what's the cons? Definitely the consequences, negative consequences, is that whatever will change tiny piece in this bigger project, maybe the entire project will need to be rebuilt, right? Because this is just one piece. And in this particular case, everything took 21 seconds. Pretty fast, right? But remember, that was a very small project. However, the same project with incremental build enabled. So on the top, we can see the same project to utilize the buildable libraries, and it looks a little bit different. So we can see these building blocks. Each represents the buildable library, and each represents the project with the ng package JSON, and project.json within the defined build target. Now, you can also see that first all the dependencies are built, and then project is built after, right? So we are using this caret build to make it work. Now, for the first run, the entire build took 19 seconds. Pretty fast, but only 2 seconds difference, so what's the point? However, if we change one tiny thing in the dependency, we can see on the bottom that only this dependency has been rebuilt and the application itself, but all the other dependencies are retrieved from the cache, which is improved, which is huge improved because the second build took 7 seconds, which is 3 times faster, right? Additionally, we can see compared to the state without incremental build that we have this parallelism, right? So we have this parallelism control via the -- parallel flag, and we can increase amount of different threads that are executed independently. I would say use the parallel amount the same as the amount of the core in your CPUs, then you'll have this guarantee each of the thread will be compiled separately. Right, you're probably thinking, okay, I want this, how should I turn this on? And there are 3 things you should keep remembering. First, use the buildable library, because buildable library can depend only on another buildable library. Second, use this carrot build to tell Nx, hey, please build the dependencies first and then build the project. And third, last but not least, build libs from source flag should be set to false to let Nx know, hey, don't compile the TypeScript files, but rather try to build things or try to utilize things from the cache. Try to utilize things from the cache if there are some pre-made distributed artifacts. Right, let's make some demo. Enough of talking. So yeah, time to get our hands a little bit dirty. I would like to show you a few things here, how the cache works, how the Nx graph work, and how the incremental build work. So, sorry. Let me quickly. Where is it? Oh. Right. Let me quickly walk you through the project I have prepared. So that was our missed slide with this invisible invisible slide. So I wanted to show you this Nx graph. So this is the project I have prepared. It contains like some amount of different projects. Projects means every single folder within a project.json file. So we can see here a project graph. However, we can change the context to the task graph. And in this task graph, we can see a one build target that is executes, that when executes, it builds the entire application. So let's try to enable the incremental build first. To enable incremental build first, I need some buildable libraries. So let me create 2 buildable libraries, Nx Angular lib. Let's call it logger1. Lib, yes, sorry. Logger1 directory will be libs shared utils loggers, whatever, and import path would be Nx demo logger1. Let's see. Hopefully I did not miss anything. This import path flag tells what should be put into the tsconfig aliases. So this is just the alias that will be mapped into our buildable library. Yes, there is a typo, sorry. Great. We have generated the buildable library inside the libs. Oh, there is another typo, but whatever, basically. Let's create another buildable library. Here. The same folder. So right now, once we'll have the buildable libraries, let's take a look. Utils. Oh, utils LBS. Okay. Libs LBS. Here are the loggers. Great, I don't need the spec file, and instead of component, I would like to use some service like logger1 with a very complex method like log message, and just let's log the message. Oh, come on. Right. My keyboard is not working well. Let's fix log message, semicolon, oh my goodness. Let's fix all the lint errors, all right. And let's just make it the same in the second logger. Now, what we'll see after we'll run the Nx graph, after created these two buildable projects. Someone knows? What should we expect?
Sorry, maybe I missed, but do you actually use them in your project?
Correct. So right now we'll see those two projects, but next to the all different projects, so they are not connected at all, right? Also, from the task perspective, we'll see the movies built and nothing else, because that will be the target that will be only used to build the entire application. So let's change it and let's import them into the projects. So I'll use, for instance, this logger one service, logger one service, and logger two service also. And somewhere in the tab, I'll say this, logger one, log message, whatever, and the same for logger two. Now, sorry, I did not import this. Now should be good. Now, when we'll change the graph, you'll see graph changes updated, right? Which is about, we don't really need to rerun things. It's only about change the files, and Nx will constantly do the work to keep the state up to date, all the workspace fresh. So when we'll take a look our projects right now,
They will not be standalone.
yes, they are connected within the project we are importing, right? But what's even more important is that when we'll take a look the task graph, there's nothing here. Why? Somebody knows? I don't know, right? So so we have created a buildable libraries, but we said that to enable incremental build, we need to make two more steps. First, we have to add the carrot build that let know Nx, hey, build my dependencies first and then build me. And we should set the build clips from source flag to false to not try to compile the TypeScript files. So let's do that. And in the project.json, we have this build clips from source flag. So we are changing it to false. Also depends on carrot build. And I need to wrap this with quotes. There it is. Okay. Now, when we'll run the Nx graph once again, from the project perspective, there will be no changes because these projects have been imported by the another projects. However, from the task perspective, we should see or not wait a second. Apps, movies, build, slips from source. Depends on carrot build. Weird. Let me try from different angles. So let me run the build. Right? And the build process should show us what's exactly built. So when we have incremental build enable, we should first build our dependencies and then we should build the application. And I see we are building the application only. So let me quickly try to fix this. Build, options, configuration, default. Yes, this is the target build. Depends on. Import things. Yeah, should work. Not sure why it's not working actually. It's like the magic of the live demos, right? What things can go wrong during the live demo? Not really. Let me check. No. Build clips from source set to false depends on Sorry, something that should work is not actually working, and I have tried out multiple times without bigger issues. Yeah, it's not working. Logger 1 service, logger 2. Build clips from source. Did I make any typo? No. Right?
If you use depends on, do you need to define the target on the libraries? Like the library need to have target build?
Yes, depends on. I should define the target name. However, let's check. Let's make this from a little bit different angle. So we have the target defaults. We have ng packager light. Depends on carrot build. And just Angular application, let's say, depends on carrot build. Yeah, that's the only thing I would like to show. No, it's not working, and I don't know actually why. We'll need to debug this a little bit more. So what I wanted to show you actually is after we set up the project configuration and specify the current build and the build clips from source, we'll first build our dependencies and then we'll build the application. That is how it should work, obviously, but I'm not really sure what happens and why it's not working. So yeah, let me finish on that. And the last slide I have is thank you slide. Hopefully you get some understanding how things work under the hood, and please keep remembering the best tool are the tools that makes you work faster but not really think harder. Thank you so much. Live demo.
Do you have some questions?
Yes, why it's not working?
I was pretty honest.
No. I probably know why it's not working. So, do you have any questions? I will fix that really immediately because I know what's the issue probably. Any questions? Lips shirt.
Do you have any questions? Please.
You have to have any questions.
I have one
The
question.
gentleman
Go ahead.
last row.
Yeah, thank you. Thank you for presentation.
I know what's the issue, just by the way, but yeah.
Okay, so let's imagine the context. You have an integrated monorepo with hundreds of packages, right? And the Nx graph is a really flat graph, which is only showing the connections between the projects basing on the imports, right?
Yes.
And that's like a bit not enough for modern humans, right? You are also interested in different flavors, in different layers. Like, I would like to see all the projects from those hundreds of projects which are having mocks on them. Also, I would like to see a different flavor, all the projects which are having the persistence layer there, or all the projects which has a connectivity, and etc. etc. We can have a lot of those layers, right?
Mm-hmm.
So if you are opening this monorepo with these hundreds of packages, what would be your approach? How to try to build this layered graph?
So how to define different flavors on
different layers. Like we have one single graph essentially, and we would like to chop it on slices, on scoped slices.
Mm-hmm.
We, off the top of my head, we can possibly use the tags on the project, right?
That was
we can put it, but we on the graph UI we cannot filter the graph
yes.
by the tags, unfortunately.
We can't the graph command can be executed directly like NxWrocław, or when we are executing the target like Nx built my app, we can add this -- graph flag to show how this command will be executed from the graph perspective. But we cannot really filter things in a command via tags, scopes or types, basically. If there's a way to filter projects, what we can do, like we are limited only to what Nx allow us to do, which is to execute some different commands like Nx affected, right? And then when we'll add this -- graph.
Your laptop is acting on the gestures.
It's this cable.
Very modern laptop.
When we'll add to this command, to the Nx command a flag -- graph, it will show us how this will be reflected in the dependency graph. But as far as I know, there is no possibility to filter via tags, types. Michael?
It's not a question, it is an addition to the previous question. And I want to point out, so you have a project base, you have a well-tested project base. So if you have a well-tested project base, you also have testing levels, right? Testing helpers, extend things where you can extend your testing library, your v-test, your chest, your whatever. And that points exactly back to the previous question. What I don't like at Nx at the moment is if I have a project and I want to build that project, I don't care about my test files and I don't care about my dependent test files, right? Like my testing helpers. I don't want to know about them. I just want to build the production artifact of my app. If I want to do that in the current Nx setup, I will have to rebuild my testing utils.
Correct.
It's not like you could solve it with an answer, right? I just wanted to point out, if Nx would join, what's your name?
Alex.
Would join Alex's opinion, I guess they would have a major feature. They would add a major feature because they would basically cut all builds of all packages that are not production.
Yes. Yes, and this is not the only kind of developer experience. It also affected on the build execution, because in the end you'll have to consider this test library package and execute it, right? Which is not really necessarily to do when we are building our application, because test and build application are the two separated things. However, right now, like you said, Michael, it's something that we'll have to deal with. There is no any workaround to have it. And even if I've seen multiple projects where next to the package that contains like a business logic, we had like a test library that imports something from this package, and out of the box the relationship is created, right? So it will be also reflected in the project graph as a separate project. And yeah, this is something that we'll not be able to fix, at least at this moment.
I have a follow-up question. I'm sorry.
Yeah.
I'm really sorry. But now my brain starts spinning. I can have fine-grained. So first, let's start with the problem. Nx is project-based, coarse-grained. I would say it's not fine-grained. It is like somewhere in the middle, you know.
Mm-hmm.
If I would remove these project dependencies, or like, is there a way, like, how we could implement that problem in the future to solve it in Nx, to like get rid of test dependencies when I build something, or is this by design from Nx a very hard to solve problem?
Probably we can introduce some exclude flag or whatever, basically, when we'll put a project name from the project.json, the projects that we could potentially exclude from the graph generation. Right now, when we are typing any command like nx build or nx affected, all different projects that are calculated by Nx that should include into this build process or affected process are displayed without any filtering. But I think it's like probably like the easiest solution to introduce some kind of option that would be additional optional next to every single next Nx command, what need to be excluded, similar to something we see in the tsconfig or any kind of particular configurations, right, where we can specify things to include and things to exclude. But yeah, that's the kind of only solution which crossed my mind to solve this problem. Should not be that easy, should not be that hard, I would even say.
It's at least a tricky thing. Thanks for the elaboration.
Yeah.
Thank you.
Any other questions?
I have a global question. What's the best way if you have like a big Angular project which has a monolith? What's the best way to migrate it to Nx?
To migrate it to Nx, so there are different recommendations, not the one silver bullet, I would say. So when you don't have any Nx applied, so when you have like 5 different separated applications, let's say, right, written in Angular, and you would like to apply monorepo Nx to connect all these 5 applications and extract from all these applications some shared libraries. Nx team recommends here like build a project, build a library from scratch, and then move the whole source code from your application into the newly created library. There are some migrators as well, but it depends which use case you would like to use. If you have like one application, there is this Nx migrate command to that easily apply Nx on it. However, if you have like multiple different, more complex situation, then I would not suggest to run the migration command, but rather step by step move your code into newly created fresh monorepo. At least this is how I would do that, because at every step we are moving our source code, we are able to check if it's actually working or not. But there's no kind of, I wouldn't say there's one way to do that based on the use case. So migrators are also a great things. But yeah, hopefully that addresses your question. Any other questions? Simon.
I have another one.
Yes, go ahead.
How much did you spend on the memes? That's a key question. That's a key question.
Not much.
So Adrian is advanced.
Yes. Thank you, Jarek, for your talk.
Thank
Big
you so
applause
much.
for Jarek, please, for the last speaker.